Okay, welcome to the evening.
It's about Selenium.
Hey, it's about Selenium, right. I just got roped into this 10 minutes ago. We got some good talks lined up, I think, and then what should be a really interesting panel. So, welcome, and let's get started. First speaker is Mark Striebeck.
Okay, first of all, it's Striebeck, not Striebeck. But all Americans do that wrong. That's fine. There we have it. So I'm a test engineering manager here at Google, and I'm working, or my teams are working on testing infrastructure, testing tools, all kinds of testing support here at Google. And over the last year, I really have discovered that Selenium really sucks. And here's a couple of things. So first of all, it is way too simple. I mean, if you think about it, other testing tools, you have to learn a language, you have to learn a scripting language. There's some really acronyms that you have to learn. Maybe you have to set up a completely new system. Selenium is so easy that pretty much, in my experience, and again, from Google, outside of Google, every self-respecting tester or developer starts writing a framework for Selenium. You don't just use it. You write a framework to abstract something, to make it a little bit more complex, make it a little bit more sophisticated than it ought to be. And then the worst thing that you guys did is you didn't even prevent people from putting all their stuff that they need for their framework in XML files. I've seen so many frameworks that put all the page definitions, all the widgets, everything in XML files. And then people, of course, discover at some point that it sucks. It's way too broadly applicable. Almost every team that I know, again, here at Google, outside at Google, I'm working actually a lot with the Agile community, so I'm talking to many people there. Pretty much every team that starts using Selenium finally, or at some point, and that's probably after a day or two, realizes you can use Selenium for pretty much everything. If it's like the normal UI testing, if it's functional testing, if it's latency testing, if it's unit testing, if it's server availability testing, all kinds of testing. Selenium pretty much works for everything. And again, you guys didn't put anything in there that prevents people from doing it. People do it, and again, after a year or so, they come to me, to my team, and say, hey, look, this whole testing suite that we have, it's just way too brittle. It just fails way too often because, man, we have all these exceptions, and of course we test them through Selenium, and we spend all our time just maintaining our tests. We can't even write new tests. Whoops. Too much language support. Again, other testing tools have their own languages. You have to learn the language. You have to understand the language. There's always features from the language that are missing, for loops, inheritance, whatever it is. In Selenium, you have Java, you have PHP, you have pretty much everything. So all the developers use it exactly as they use the development tools, making the tests much, much more complex than they actually need to be. Don't even trying to learn this as a testing language. No, just using it as an extension to the normal development language. And then the worst thing is, you support all these languages. The one language that you don't support is C++. Here you have at least some people who know what memory allocation means. So people who could actually work with it. No, you have all these tools, all these languages that hide all this complexity, and people write tests that are at least as brittle as their code is. Next thing is, it's parallelizable, and with the grid you actually made it parallelizable. So we told people in our industry for months and years, write fast tests. Don't write small tests, it's bad. They're brittle, it takes too long until you get the results, they're bad. You have to write them faster. So now we can parallelize all these damn Selenium tests. So now everything that was before an hour suddenly executes within 5 minutes. And I'm running out of arguments why I tell people, look, your tests shouldn't run that long. They come back to me and says, hey, they return after 5 minutes. Must be good. The multi-browser support. So that's something where pretty much everyone starts with. This is cool in Selenium. It's Firefox, it's IE, it's Safari, it's on all these OS, on Linux, on Mac, on Windows. Has anyone actually ever tried to using all these combinations and running your tests on all these combinations, manually or on a farm? No. And we tried here. And Jason can sing a song from that. I stand in Jason's cube at least once a week because something on some browser OS combination doesn't work on some specific version of Firefox, on some specific version of IE. And I get the heat, and of course, well, I'm Jason's manager. I don't take it. I give it to Jason. so poor Jason, who developed Selenium now, has to deal with this. All these browsers, all these things that people actually want to do, that people actually want to use, and that don't work. And as a last thing, actually, my job here at Google is I'm running the Selenium team here, so I'm funding it, and I'm getting all the heat for it. Thanks.
So I'm up next. My name is Patrick Lightbody, and I'm going to give a brief overview with a lot of quantitative numbers of how Selenium's been doing since about January 2007. What I do is I was the founder of OpenQA, which is kind of the home of Selenium, and I actually started a company around this whole grid concept of Selenium back in late 2005. May have been a little ahead of its time. It was called Hosted QA. You can't find it anymore, but I'm still chugging along at this company called Gomez, doing similar stuff. So my only plug I'll do is if anybody's looking for a really cool distributed grid-like thing that these Google guys talk about a lot but won't give you access to, come talk to us and we might be able to help you out. All right, so let's get started. Overview of traffic. You know, obviously these aren't super impressive numbers by MySpace's standards, but we're pretty proud of them. Along the bottom here is kind of a timeline from January 2007 all the way to basically today, and you can see there was a nice upward trend going along, and then we got this great spike in the last month or two. Overall, we've had almost 1 million unique visitors, a lot of visits, a lot of page views, a lot of interest in Selenium. In terms of how you quantify that interest, and by the way, of course, this is all coming from Google Analytics. We've got a lot of different ways people are getting here, but obviously primarily through search engines. What a surprise! Most interestingly is that the search terms Selenium, the top 5, account for 92% of all OpenQA's traffic. There's a lot of demand for Selenium, and I don't think these are people just looking for the weird minerals to make their back feel better or whatever Selenium does. So this is encouraging to us as a team, all the people that are sitting up here, that there's so much interest. In terms of what they're actually interested in, is both core, IDE, and remote control. These are not surprising. They're the 3 main projects, and they're equally distributed in terms of what people are coming to and learning about. We do have a Rails-like project, which may or may not be evolving in the next few months, and then of course this new grid project that just went live in the last few days or weeks, and we expect those to grow in terms of popularity as well. But it's a very dynamic universe of projects, and I'm sure there's a lot of people out here that are using 1 or both or 3 of these different types of technology. So we're really happy to have this strong ecosystem. Something we just found out about was that we could track project downloads. I wasn't looking at our Apache logs lately, and we looked at it, and we were quite pleased to find out that Selenium remote control at one point topped I think just about 50,000 downloads last month. And again, these aren't the biggest downloads in the world, but that means that there were roughly 50,000 people interested in checking out just remote control. If you combine all 3 projects together, we had almost 100,000 downloads of these released projects. Most impressive is that we're going to see some of the non-exciting stuff, the kind of sad stuff about Selenium in a moment here, that we only had 1 release, and people are still interested in it. So we're really excited about, what if we do more releases and we have more features? We think this is going to be even higher. So we're really excited about everyone here who's interested in Selenium and downloading this stuff, and there's a lot of interest, and it's showing. In terms of source activity in these projects, primarily a lot of the focus is on Selenium remote control. Not surprising, that's one of the more complicated components. Just curious, quick show of hand, who here uses remote control? So yeah, it looks like roughly about half, and that matches up nicely with our effort. So look at that, that's perfect. But over the months, we've had different developers getting involved at different moments. But for the most part, we're again kind of equally spending our time on the different projects, but remote control is where we see a lot of the future of Selenium in terms of when people really get involved, they do get involved in remote control when they go deep. The nice thing, though, is that IDE is a fantastic tool. You guys will get a demo of the next version, which has some really great features, and that's also getting a lot of attention. In terms of breakdown, we're a little ashamed about this, except for the 3 people, or 2 people actually. My name's up there, and that's unfair for my name to be up there. I meant to edit this. The contribution's a little weighted, as you can see. We've got one fellow up here, Dan, who we should all be very happy for his existence, who contributed almost half of all the code last year. You know, he's a machine, and we know that that's not totally something we can continue to do. Shinya, who is also here, and we're happy to have him here. He flew in all the way from Tokyo, and the creator of Selenium IDE, which I think is how everybody generally gets introduced to Selenium, also is very active. My activity is fake to a certain degree. I was just working on the website. I don't actually code much right now. But we're a little lopsided, and we recognize that, and it was great that we had this event where we can all come together as the development team, see where some of our problems are, and improve that. Similarly, we had a lot of posts in our forums. I know that here at Google there's some internal mailing lists and discussions that also happen, but on the public side we had quite a bit of posts equally spread across most of the projects again. And again, Grid is kind of up and coming and getting some interest because it's a really exciting project. You're going to see some cool screencasts here in a minute. But again, we were kind of weighted with Dan and Shinya there at the top contributing to most of the answers in these little forums where people get reward points. One thing that was nice is that there were people who aren't developers. A lot, you know, this guy Constantine, he's not a developer. He just answers questions, and that's kind of an encouraging sign of a really strong community. We need to do a little bit better though on the forum activity. These are some graphs that I don't think we really care about. They're just messages per day. The one that's a little more discouraging but also encouraging about the opportunities is our reply rate. In the upper right-hand corner is Selenium Core, Selenium Remote Control, and IDE, but I guess it doesn't really matter because if you see the pie, the big red slice in the upper right-hand corner of all of them is the questions that never receive a response. And so we're a little embarrassed about that, somewhere between a quarter and a third of all questions that are asked on the forums just don't get anything. They go into the echo chamber. We've actually instituted a policy since we met up where we're going to kind of be more on duty and be a little more active about it and try to find some other creative ways to respond to these things. That said, we have had a lot. That means there was still another chunk where we did reply and got a lot of responses. So we've got, again, a kind of active community and just some little challenges here. In terms of bugs, probably not as many bugs filed as there really are, and we've been guilty ourselves of not properly filing bugs and following a better release process. And considering that we're a quality-oriented tool and a process-oriented tool, we probably could do a little better around that. And again, Dan and Shinya saved the day. So this is where it really highlights that even though I was in there coding, I wasn't actually doing anything useful. And the rest of us, we're shamefully at 1 or 2 bugs. But that's all right. We actually already had just today I think we did some bug track pruning and all sorts of fun stuff in there. So there is activity, and we again expect to see some progress this next year. One of the things that we're kind of most disappointed about, but also have some encouraging news to tell you in a moment when Paul comes up here, is our releases. In 2006, we did, between the different projects, between 5 and 9 releases of these different projects. In 2007, they only all got 1 out, and we know we can do better. There's a lot of exciting development. There's obviously a lot of bugs and improvements we can make, performance, a lot of fun stuff, and a lot of required stuff that we need to get out. So I'll leave that to Paul in a moment when he'll talk about sort of our roadmap and where things are looking there. But overall, we're pretty excited. Selenium's more popular than ever. We couldn't have done this a year ago, so we're glad that you guys are all here. We've got a pretty strong ecosystem with lots of different projects that meet different people's needs, but there's a kind of cohesive vision combining it all. We do have some lopsided contributions in different areas, but we also have a renewed focus, and so we're really excited about our roadmap, and we'll be sharing that with you in just a moment. Thank you very much.
Hi, I'm Jason Huggins, test engineer at Google. I'm just going to briefly describe kind of what Selenium is. Well, for the people who just found themselves sitting in a chair here and don't quite know what Selenium is, I'll just briefly say what it is. So it's meant to be a test automation framework. Some people abuse it to do other things, as like a macro tool to do stuff. Anyway, it's meant to be a very sophisticated automation, and it works as your users do. It's supposed to. What was that?
Is that version 3?
That's version 3000. I think in the Google Labs somewhere on the Googleplex. So that's what it is. But there's two reasons why Selenium got its where it is. Like the reason what makes it special. It was able to test Ajax before all the rest of the tools. So it was kind of like where Selenium came from when we originally created it. We were doing Ajax before it was called Ajax, and then that word was coined, and then people started looking for, how do I test this stuff? And Selenium just kind of fell into that role. It's not the only kid on the block now in the Ajax testing kind of space, but anyway, Selenium got the momentum there. And the next one is when you have to do this workflow testing, otherwise called happy path testing, things like that. From in this case, I'm trying to share a Google document with Larry and Sergey, and I'm going to add them as collaborators, and then click the save button, and then make sure that there actually are collaborators and things like that. So it's testing those kind of scenarios. And then this was the other thing of, I guess you could argue of like, is this where we are today? But this is what we want to today say that we cover, in the sense that we cover, at least at the middle tier, be a quality testing tool for testing web apps in Safari, Firefox, and Internet Explorer on all the different platforms on the top. But then also another kind of differentiator with Selenium is that we're not just a Java tool. We're not just a Ruby or a Python tool. But we support these languages to write your tests in. And then because you're testing at the web layer, you can test then, because it's just a web app, any PHP app or a Rails app or a Java app, things like that. So we try to be multi-language, multi-browser, multi-platform. It's ambitious. And a lot of tools, you could argue, are more successful at picking one browser, one language, one platform. And this problem is hard, but we attempt to do this anyway. And then briefly, we're talking about all the different products within the Selenium family, and I acknowledge it's incredibly confusing. It should just be, well, I don't know what it should be, but what it is 4 products in the Selenium product family. This was my baby. Originally back in 2004. We never quite know what to call it, but it's Selenium Core now, otherwise known as the test runner. And you can see just briefly, there's kind of 4 segments to this thing. In the top left, you have a test suite definition. In the middle, you have a test written in HTML, the bastard child of XML. And then a little control panel, and you got your app that runs down there. That was used as a dependency, which made Selenium even cooler, was the IDE for Firefox. That has a lot more capabilities than Core has, and it's just even more all singing, all dancing. Anyway, so that drives a lot of traffic into the project. I'm just going to fly through these here. Next, we have Selenium Remote Control. It's hard to visualize just random code that runs in the ether, but effectively, this is the way I always visualize it, being able to turn on a browser and then fly it like a plane, remote control-wise. And that's Java-based, but then you have all the languages that can connect to it. Up and coming is the Selenium Grid. That's a screenshot from the matrix. And so all of those little things in those pods don't quite know that they're in the matrix, but they're controlled by Selenium. So we try to, as far as like the product is out there, so that's where we are today, but also be a big part of the future. And so that's just briefly kind of the 4 families: Selenium Core, which is now more of a dependency, but Selenium IDE for Firefox, remote control, and then the future, and the current, the grid. And Paul Hammant from ThoughtWorks will now be talking about the roadmap for Selenium.
Hi everyone. So first thing we want to do is announce Selenium 1.0. It's not happening today, it's not happening tomorrow, it's not even happening this week, but it'll happen 1 week soon. But we're going to precede it with a beta release, which is going to happen this week. I kind of wanted it to be today, but the guys clipped my wings, and we're being more sensible about it and pushing it out sometime this week. Essentially, it amounts to a roll-up of the current situation, which is a fairly working platform, but none of the sexy new features that we'll come to in a minute. It's essentially just a bug-fixed release, greatly improved documentation, a better landing page. I don't know if anyone's ever seen the current Selenium landing page, but it really doesn't describe which version of Selenium you should be using, and that's probably going to be clearer with this release. So Selenium 1.1. This is like a commitment to ship the stuff that we are cutting from the current release that's in process and is going to be firmed up and ready to use, maybe in beta at least, or at least from the nightly snapshots. It'll be ready in a few weeks, a month as well. And substantially it's leveraging something that Shinya is going to show you later, which is a greatly improved IDE. So you saw a screenshot of the IDE a minute ago on Jason's deck, but you'll see another one coming up in Shinya's, which is far more impressive and most people won't be able to wait for. We're also hoping that with the SDK released from Apple for the iPhone, we'll be able to target that platform. So we kind of know how we might do it, but we're going to wait until it's all legal to do so and push out a new binary for that to hopefully allow that to be in a Selenium grid. So the last slide from me, 2.0. Sometimes this year we're going to ship this thing. Substantially it's going to leverage WebDriver, which Simon's going to speak about later on, which is a new way of working with testing of web applications, leveraging a different set of technologies than the ones that we've previously been adept with. And rather than simply drop what we've done before and go down Simon's road, we're going to merge all of the best bits of both projects together and call it Selenium 2.0. So for the record, it's going to count an Internet Explorer plugin, which means it'll be able to listen on a plugin for instruction from an RC node and steer and test a web application reporting the data back. It's going to have a Safari plugin. So this is not really a plugin. It's more of a cooperative process, and it's in theory firing AppleScripts events around, which make the machine pretty busy, but we think we can do it, and Simon's been doing the prototyping on that. And this model-driven API, which Simon will talk about in a minute, is actually a far smarter way to develop tests for. Perhaps the QA professionals who've previously looked past Selenium will look at this one and say, oh, it's now quite a sophisticated tool, because our previous API has been variously described as a sewing machine operation between RC and the clients in question. So that's it for me. And next up is Philippe.
Okay, good evening. I'm Philippe Hanrigou, and tonight I'll tell you about Selenium Grid and how it fits into the Selenium landscape and ecosystem. So first, let's back up a little bit. Testing is good, right? Especially when it's automated. You know, you get regressions, you have better quality, and more importantly, you keep your customer happy and the cash flowing. The problem is, end-to-end web testing is kind of hard to automate. But don't worry, we got the tool for that, Selenium. Selenium is awesome, cross-platform, cross-browser, being there for a while, big community support. So we solved our problem, right? We're good developers, testing is good, Selenium is awesome, let's write a bunch of Selenium tests, and we're going to live happy ever after. Sure. Actually, what's going to happen is more something like this. Because I forgot to tell you about something. End-to-end web testing is slow. So basically, your builds are going to take hours, and your tests are going to wait a long time for Selenium to do its magic. And the worst problem is web testing is slow and will always be slow if you consider end-to-end web testing. You got tons of network chats between browsers, web servers, application servers, database, cache servers, you name it. So it's always going to be slow. We're not going to solve this problem. And you remember this picture? Actually, that was an idealized view of how this is going to end up. Because in real life, what's going to happen, all your tests are going to be slow, but some are going to be slower than others. And you're going to end up with something like this. Not so cool. So what are we going to do about it? Just give up? How are we going to solve this problem? Well, it turns out we solved this problem already. We're building highways with multiple lanes so we can handle traffic, and traffic going at different speeds. So that's what Selenium Grid is about. Giving you all the Selenium goodness, but with multiple lanes. You can run multiple tests in parallel. So you could do it the old way, or the traditional way, running your tests serially, one by one, going home, getting an app, going back next morning, seeing that half of your test suite failed, and you wonder why. Or you could use Selenium Grid and run 20 tests in a row using Selenium Grid. Here, this is my MacBook Pro running 20 browsers at a time just using the grid. So what? You like it? So what's the advantage? Well, you get faster builds at almost no expense and faster feedback. If you got faster feedback, your maintenance of your application and maintenance of your test suite too requires some maintenance is way better and way quicker. Also, like what makes Selenium Grid kind of unique is that it's from day one it has been designed to be easy to use and easy to install. So I expect you to be up to speed and up and running about 10 minutes after downloading it, at least running a demo, which is documented on the website. Also, Selenium Grid does not want to be too intrusive, doesn't want you to write your test in a new way just for the grid. Any test that is currently targeting running against the traditional Selenium remote control will run against the grid out of the box. You just need to change the hosts you're targeting. And last but not least, even if you're not working for a big company with huge data centers to spare, the grid is still for you. Because a couple of Mac Minis, laying around can go a long ways into shortening your build dramatically. What experiences at ThoughtWorks, starting with build that took hours, 3+ hours, to minutes, 10 minutes, 15 minutes, using about 2 several Linux machines and just 3 or 4 Mac Minis. So you don't need to invest that much money into your hardware. And actually, even if you cannot convince your manager to use some hardware and to buy some hardware, I'm really excited tonight to announce that you have another option. Per user request, the latest release of Selenium Grid now comes out of the box with Amazon EC2 integration and automation support. So just download it, run the demo, and have fun. So what should you remember about this talk? Just one thing. You need to go to Selenium Grid website, selenium-grid.openqa.org. Download the product, try it out, make it part of your build. If you like it, or even if you don't like it, especially if you don't like it, don't forget to give feedback so we can improve the grid. And if you really like it, hey, just join the team and become a contributor. So next time you download it, it's going to be even better. So if you get lost in the way and you wonder where to go, almost all the information about Selenium Grid is on Selenium Grid website. You can ask for help and advice on Selenium forums. And if you want the latest news about Selenium Grid, or if you want to contact me, you can use my personal website, which is ph7spot.com. And that's it.
Hello, I'm Jennifer Bevan. I am the lead for the Selenium project, the Selenium Farm project here at Google. What that is we put several Selenium machines on a grid last year, and we've learned quite a few lessons from that experience, and I'm mainly here to share those with you. So as of Friday, we have over 50 teams running these tests. On Friday, we recorded over 51,000 tests. That's pretty average for a Friday these days. We definitely do show a variant of usage because a lot of our tests are driven partly by continuous integration machines, and some are driven by developers just trying to see whether or not they broke anything. Now, from these tests, we have found that about 96% of these tests, they actually work quite well. And this would be great if we weren't running 51,000 tests, because it means that there's still 4% of these tests that are failing for one reason or another. And one of the problems that we're finding is we can't always identify whose fault it is. We look at these 4%, we can say these 2% are clearly Selenium or clearly user problems. And the other 2% are split between ones that we think are user problems and that we think are Selenium problems, but we don't have enough information yet to be sure. So on the other hand, the 96% has meant that Selenium has been adopted by so many projects, and it is now mainly the default web application testing tool here at Google. That's the good news. But we're pushing the limits. We're pushing the limits of how fast we can send tests through RC. We are coming across the yaks in the road, so to speak. We have, say, several hundred tests that can run fine against Firefox, but when we need to test them against IE, if they're using XPath, the slowness that is on the forums about XPath and IE really becomes a bottleneck, and people find that these tests are impossible to run unless you fully parallelize them and you don't have any other problems. So that was one side of things, is the unexpected slowness. The other problem we were having is the actual tests themselves can actually dramatically decrease the effectiveness of the farm. You can do things to these machines that are actually rather hard to recover from. The grid is operating as a manager. It's effectively a multiplexer for these remote controls, and the tests themselves are able to get Selenium RC into a condition where you literally have to just shut it down and restart. And we don't want that to happen because then someone has to physically either go to the machine eventually if it gets very, very hosed, or otherwise you have to write a lot of maintenance code into the farm or the grid. In addition to this, one of the other problems that we come across is tests that are trying to write Selenium tests that are nevertheless causing problems that are not handleable by Selenium. You have these unexpected browser pop-ups are the most common, right? And the idea is there's not a clear indication of the Selenium will run your test, and if you try to do something that is outside of this box, it won't just warn you, it will go ahead and do it, causing these browser pop-ups or modal dialogues, as Dan insists on calling them. And then your test just sits there and either times out, if you're lucky, or it causes some other long-running problem. So what are we doing? Well, in terms of addressing our current needs, we have a lot of very creative developers here that don't like getting stuck behind RC. So we actually have had a lot of in-house work creating, either in-house utility methods all the way up to domain-specific languages, and as Mark mentioned, frameworks, just to get the Selenium up to the level of where it needs to be used. And projects are also developing retry policies. We're taking the messages that we get back from the farm, trying to figure out which one of those we think are not because of the test, and trying again on a different machine. This actually does help. It means that you overall can do a confidence vote on whether or not this test passed or failed. And since you can't get a false positive out of Selenium, it's actually not too bad of a retry policy. However, they still want more. They want to be able to operate outside of the JavaScript box. They want to be able to know this test is broken and it will always fail every time. That's actually pretty easy. But they also want it to pass every time if it's correct. And that is not the case today. And when it doesn't pass, they want to know exactly why, because this informs the retry policy and it informs the test writers. Did they do something illegal? Did they do something they're not supposed to be doing? Or is this really a Selenium bug? And we need to have a better communication with RC to find out what these reasons really are. But look at it this way. We still are adding people every single day to the farm. It's not just projects adopting Selenium. It's individual testers just saying, I want to know if I broke something. And they're able to just write a test to try it out. And we have seen a growth every week for the last 8 or 9 months of new projects, new tests on the usage of the farm. However, we still have some projects who cannot use the farm. Specifically, they need to use certain server command line configurations that we're not supporting on the farm. And some of these, there's no reason why we shouldn't be able to parallelize that. But because something is command line instead of session-based, they have to actually instantiate the server themselves. And this has caused a few complications. There's also a few other things better support for. I'll be happy to go into a lot more detail, but it's a lightning talk. Mostly they just want it to be reliable. And so what are we going to do? Well, I'm now a developer for Selenium RC, and we have a lot of people here who are interested in contributing back to Selenium RC, and we are going to keep doing that. And we will be working with all of Selenium and making sure that we help it become the project that we want it to be for our own needs. Thank you. And Dave is next.
Okay, how many people use Ruby? Ooh, nice. Are any of you using RSpec? Very good. Okay. I'm just going to talk briefly about some stuff I've been playing with the newest feature of RSpec, particularly using it to drive Selenium. Yeah. This is one of my sample Selenium tests. And this is written using the story test runner in the latest version of RSpec. That came out in January, I think. This uses Dan North's concepts of behavior-driven development. So just reading quickly through the test, this is a user story. We want to search at Google, right? Just a comment. And our stories are divided up into scenarios. So one scenario here, search for me. I'm not narcissistic at all. So given something exists. So in this case, given that google.com is out there and reachable. Right? When the user searches for the string Dave Astels, then it should come back, it should find daveastels.com, it should find something on Wikipedia, something on Artemis, something on Amazon. Right? So very high level, very abstract. It doesn't really talk about web testing at all. There's nothing about components on the screen, text fields, buttons, any of that. It's just talking in a very domain-specific way, what's going on. What are we doing? What are we expecting? This is a Selenium talk. So we use this, or I've used this to drive Selenium through Selenium RC. So if you notice here, if we switch back, we have given a URL. When the user searches for something, then it should find, and it should find. The ands just create new thens, right? Whatever was last used. So if we look at how that's implemented, at the top is our given. It takes a URL, and there's about a block of Ruby code that takes that as an argument and does something. In this case, it opens it in Selenium. When the user searches for this search string, it uses type keys to enter that string into the search field, presses the button, and waits for the result page to load. Then it should find some result. We look to make sure that there is an anchor with an href matching the URL fragment that we entered. Notice at the top in the yellow is steps for Google search. So this is defining a library of step implementations and giving it a name. And we'll see in the next slide, we use that. The top is a little runner script that actually causes this to be executed. And the yellow line says, with steps for Google search, the same ID as we had in the library definition, run that text file, which contains the story that we had in the first slide. Down below is a little helper snippet that loads in the step libraries that are going to be used and sets up Selenium. Oh, right. This is the output. If you run all.rb, this is the output that you get. So it essentially echoes the story. None of these lines are annotated, which means that everything worked okay. If there was a problem, these would start being marked either failed or pending. Right? If we got a timeout, they'd be marked pending, and the rest of that scenario would be skipped. Right? And down at the bottom, it gives a report of exactly what happened. And I've got a really simple URL. So rspec.info, that is the landing page for rspec, and all the information's there. So if you're using Rails, it's a really nice way to do your functional testing. If you're writing a J2EE app, it's a nice way to do your testing if you're interacting through the browser. Now the nice thing, I'm just going to skip back very quickly to there. As I said, nothing in here talks about manipulating a browser. Right? So you can use RSpec to drive through Selenium RC to test through a browser. You can also use the same story with a different step library implementation to test through a different route to your app, whether it be RPC or directly accessing your underlying classes. All right, if you're using JRuby, you can directly access your Java object classes, your domain classes. So it's kind of neat. Check it out. Have fun. And next is Alex Chaffee.
Okay. So I guess this is the Ruby ghetto, because the next talk is also about, well, what's going on here? There we go. So this is by the way, I do want to admit right out that I did throw this together 3 minutes before I got here. So I realized in listening to all the great stuff about the grid and about the RSpec story framework and stuff that I think I want to give a different talk than the one I made slides for. So let's just walk through these slides and then just listen to me. If the slides diverge, then it's their fault, not mine. So about 2 years ago, we started. I work for Pivotal Labs, consulting company. We've got clients big and small, mostly around the Bay Area. And about 2 years ago, we started a Ruby on Rails practice. And we started using Selenium because they have Ruby bindings. And we found it indispensable. We use Selenium on every single one of our projects now for all of our startups and all of our big clients, and everybody loves it. And I just want to take this opportunity to give another round of applause for the Selenium team. Just everybody. That's good. So as Mark warned you all, it's impossible to use Selenium without spinning off a framework. And so we sort of felt like we had to, because we were doing it on so many different projects, we needed to unify it. But the problem is that we weren't quite sure where the boundaries were between us and the Rails libraries and the RSpec libraries and the existing Selenium on Rails plugin. We weren't really sure what that did anyway. And we had a couple of half-baked abortive attempts to spin this out into something that we could then recontribute. And so it got about 3 or 4 different names along these past 2 years. And I'm just going to leave that hanging now. Fortunately, by a strange quirk of fate, I'm actually right now working, literally sitting right next to Paul Hammant. So with any luck, he'll badger me into contributing these back into core, and you guys are all just going to be able to use it. And so you don't have to worry about the name. It'll just magically come out in Selenium 2.0 or whatever it is that we get there. So what is it that we added to the existing Selenium framework for Ruby? Well, we discovered that things like launching servers, we do a lot of development on a single workstation, and launching servers and making sure that they're running or not running or whatever was getting to be a real pain in the neck. So we wrote this system called Funkytown, which was for functional testing, and it deals with launching the Selenium RC server as well as a JS unit equivalent, right, for doing JavaScript testing, also in a browser. We also added some library code. So we wrote a test side wait for. In other words, inside of our Selenium tests that are written in Ruby, we want to do a wait for condition to keep polling the browser and asking whether something has happened. Now, the Selenium core had a JavaScript version. We found it very useful, without going into too many details right now, to have a client-side version as well as a server-side version, or a browser-side. The terms client and server don't really mean much in Selenium land, do they? I think we should somehow come up with different names, but as you can see, I'm not very good at coming up with names. So let's move on. One part that I want to describe is what I'm calling gray box testing. I'm sure someone else has used this term to describe something else. But basically, the idea is in black box testing, you're sitting outside the box, you send it input, you get to see the output, and that's it. In white box testing, you get to kind of open the lid and look inside the box, right? We're doing something that's even different from that. What we're doing is, because we have this cool round trip, right? I'm going to show you a diagram. Here, I'll just move to the diagram part. We have this round trip going in most of our Selenium world, right? The Selenium tests that are in Polonium or whatever, where the test suite runner that either a developer launches or that the continuous integration build box launches, it's running both the test suite and a test version of the app, talking to a local sort of private database. And so we get this neat round trip through the Selenium server into the browser and then back into the test suite, which means that our tests, how am I doing on time? Pretty good? So that means that our tests can look like this. If you notice, we're doing the typical Selenium stuff, right? This is the Ruby bindings. It shouldn't look that unfamiliar if you're used to Java or whatever. But basically, we're saying, type the username into the username field, type the password into the password field, click the submit button, and then we assert text present. OK, we're still in a black box land now. But then in the next line, we're actually going into our database and making sure that that user was created. Now, I just want to know, show of hands, how many of you are using a similar technique when you write Selenium tests? So it looks like about a third to a half. So if nothing else, at least try to experiment with this. You can get into a lot of trouble if you do this, but you can also get a lot of power. So again, here's a more, where is it? There is a more elaborate example. As you can see, after the black box stuff from the first 5 lines, right, where we're asserting the text is present on the web browser, that the email has been sent to the user, we then have a line where we're actually doing a polling weight inside of our test process, checking not the database, but we're actually checking this mocked out Rails object called Action Mailer. And this guy is waiting for the version of the application code running in the same process to send email, right? So we're actually, there's no database involved. We're still sort of up in the air. But what we've done is we've set up this Action Mailer in test mode, which means it doesn't actually try to deliver. Instead, it's working more like what we would call a spy, where it takes whatever it was given, sticks it away in memory, and then later on we can query it, right? Then, that's not all. We can then move along and we can query that email that we got to make sure that the correct verification link was sent with some random encrypted number, right? Then we can click on that number by saying open link. Are you with me? Right? So the app is actually making a random string. It must be random, right? Because it's this encrypted authentication link. And then in our test, we go and click on it that we got from our email, which we stubbed out. And then later on, we can finally, in the wait for, the second wait for, we can make sure that in the database, the user actually got verified. Right? So we're using this remote control. It's like that remote control handset that we saw earlier that Jason showed us, except we've got like so many dials and knobs on it, we don't know what to do. Anyway, this is all real. It was extracted, and some of the names were changed, but I just want to show you that extract link. All we're doing is a regular expression match on the text of that email. There's nothing magic going on here at all. Anyone can do this with the existing Selenium RC architecture and then some useful functions that we've added on top. And I guess we get to access email again. Okay. Like I said, whipped it together 3 minutes before. And then, of course, we love extracting a DSL. What Dave showed us is a DSL that you can build that's more elaborate than this, but this is a good way to start growing your own DSL so that instead of your code looking like this with all this nasty stuff, you could extract that top part, right, the top 4 lines into submit new email, right, or create new user. And how are we doing here? 49 seconds. Yeah? Or am I done? Okay, anyway. So let's see, I talked about that, and I think I'm done. Oh, one more thing. I wanted to mention our Mac Mini setup because somebody else mentioned Mac Minis. We've actually got some CI boxes that are really cool. It's a Mac Mini running Parallels, and it runs 2 Parallels VMs. And one of them is running Linux, and that's actually running our continuous integration system, including running the Selenium tests, and also doing a deploy test to make sure that it can deploy to a Linux box. Right? And then that guy is actually talking to 2 different Selenium RC servers. One of them is on the host Macintosh OS, and one of them is on this other Parallels instance running Windows. And it all just works, and it's really cool and magic. And if you put Parallels into what they call coherence mode, then you actually see IE running inside a Mac, and it's really gives great demo. Unfortunately, the Mac Mini only has 2 gigs of RAM limit, so we're going to have to move to a different platform. But it's really cool. We actually sell our clients CI Mac Minis that we just sell them for cost. We walk down to the Apple Store and buy them, and then we hand them over when the gig is done. Anyway, thank you very much.
I am Dan Fabulich. I work for Redfin Corporation. Redfin does online real estate. That seemed like a really good idea like a year ago. And as you know, I fix a lot of bugs in Selenium. I'm really passionate about this project. God help me. And what's really weird about it is it's just this enormous paradox. How could something so bad be so good? And how could we run a project so bad and yet have such great success and have a room full of people here who want to hear what we have to say? I have no idea, but I'm here to tell you how to run a successful open source project wrong. One thing you definitely don't want to do is support everything. For heaven's sake, we support operating systems, we support all the browsers and all the operating systems, and that means that you're working with third-party code, code that you don't own, can't see, it's Microsoft code, they're not going to talk to you, and your users want you to support everything. They want you to support things that aren't released yet. They want to test Firefox 3 beta. Firefox 3 isn't out yet. It probably doesn't even work. Sort of works with Selenium, though, and if there's a bug in it, we should fix it right away. Because we want to fix it before Firefox comes out, so that you'll be ready when Firefox 3 comes out for your app to work right away. This is a terrible idea. If you can avoid it, don't work like this. We wrote the whole thing in JavaScript, for God's sake. Why did we do that? Well, one thing, it made it really hackable. I mean, that's good. You know, everybody knows JavaScript. It's one of the weird things, you know, like you got Java people who don't do any Python. You got Python people who don't like the Ruby people. You got the Ruby people who sneer at the PHP people. But we all come to the table with JavaScript. We're all forced to work in this language. And we all know how to work in it. We all know how to fix bugs in it. And I can read a patch that a Pythonista sent me, and I can read it. I know how to use that patch. I know how to incorporate it into my app. But there's problems with JavaScript, as we all know. I mean, it wasn't really meant to support this enormous AJAX world and application and testing framework. They put you in a security sandbox, and that means that there's some things that Selenium just can't do because we're running in this sandbox. We're chained up, and we're unable to do the things we would really wish to do. Like, you know, sometimes you want to click OK on an SSL warning, and, you know, we're in JavaScript, and it's really hard to do that. You know, we write other code to try to make that happen. But, you know, for heaven's sake, if you can avoid writing your code in a language that is bound by other people's security restrictions, for heaven's sake, save yourselves and don't allow this to happen to you. And friends, do not let friends roll their own multi-language remoting. Look, it seemed like a good idea at the time, and I was drunk. I'm wrong, and I'm sorry. It's, you know, it's a CSV kind of thing. It doesn't have JSON or YAML or nesting or trees. And, you know, the only reason we did it was so that we could provide support for Java and .NET and PHP and Perl and Python and Ruby. It's the only thing that was really supported in all those languages, you know, more or less the same. And, you know, so we wanted to support all those languages, and so we gave this little CSV thing, and we thought, you know, okay, we've got an API, we can define it in XML, and that means we should be able to generate all the language bindings in XSLT. I actually use this book, and I use it, and I like the picture at the front of this book. He seems very disappointed in me. I'm very disappointed in XSLT. You know, I think Jamie Zawinski said something like, you know, you've got a multi-language remoting problem, so you might decide to use XSLT, and now you've got 2 problems. This guy reminds me of my dad. And because we wrote the whole thing in XSLT, because we rolled our own multi-language remoting thingy, it's hard to get other people to help me fix bugs. I feel like Sometimes I'm all alone in this world, writing Selenium, fixing its bugs, and it feels really good to see you all at a conference and ratify that my existence has meaning. I'm glad. I wouldn't know it because I never talk to the users. You know, I don't answer anybody's questions, and they're so important. They need help, and we've got these forums, and we try to help people, and yet there's so much more we can do, so many more features we need to deliver, so many bugs that we have to fix, and we never do. And above all, if you can help it, never release 1.0. I think we've been in 0. something for 5 years. I think it's time. It's time to be 0.9.9.9. Oh, you're right. That's exactly what it's time for. All right. I think that's it. Thank you very much.
Okay. I'm Shinya Kasatani, and I'm a developer of Selenium IDE. And today I'd like to talk about the quick introduction of Selenium IDE and talk about the new features that were implemented recently. So this Selenium IDE is a Firefox extension, and it's recording the search in Google, and it's verifying text. That's the URL is in the result page, and you can play that. Play what you have done in your browser, and so this is the recording and playback feature of Selenium IDE. And oops, before that. Another great feature of Selenium IDE is that you can export your test case into the real programming language using Selenium RC, and yeah, this is the Ruby program that does the same thing that you have seen. Okay, so yes, we'll be releasing 1.0, and I'd like to talk about what will be the new feature in Selenium IDE 1.0. So, okay, the biggest change in Selenium IDE 1.0 is test suite support, and here we're adding a new test case, and you can see that there are 2 test cases on the left side, and it's recording a new test case, and yes. So this is the new test case, and you can see that there are 2 test cases in one test suite, and of course you can run the whole test suite. Okay, so that's the test suite support. And another feature in 1.0 is the improvement in recording feature, and this is a test page included in Dojo Toolkit, and it records the clicks on tabs. And the previous version in Selenium IDE recorded only basically recorded only links or buttons, but in the new version it detects the modification of DOM, and if it's modified, it's the how do you say, if the click generates the modification, that click is recorded like that. So you can record Ajax apps more reliably in 1.0. And there's also a nice feature that you can select element locators. So if you don't like IDE and you prefer XPath, you can choose that. Okay. So that's Selenium IDE 1.0, and we have another great feature called UI element, and it will be presented later. And finally, I'd like to talk about the goal of Selenium IDE, and it's the goal is to get more people interested into test automation and help the project to be successful. And so far, I think the Selenium IDE has done a pretty good job to make people interested, but I think that not all people were satisfied with it because you cannot edit complex test cases, or the Ajax apps weren't recorded properly. So I think the 1.0 release is a bit straightforward to that. So the 1.0 beta will be released really soon. So please try it when it's released. Thank you.
Hey everyone, my name is Haw-Bin Chai, and I work at, okay, can you hear me? My name is Haw-Bin Chai, and I work at commercehub.com. It's in upstate New York, Albany. It's got a lot of snow now. As you can see, I've got a white background, very impressive. Okay, so I would like to ask, how many people here actually use Selenium? Okay, pretty good number. How many people use Selenium IDE for anything? Okay, looks like about maybe 15%. Okay, I'd like to talk about recording readable and maintainable tests with Selenium IDE, but there's another aspect of this as well, and I think it's usable whether you're using the IDE or whether you're using Core or the RC. So first of all, I'd like to just show you traditional locators. You're all familiar with these. Just identifier, link, or XPath, and there's CSS as well. When you record with the IDE, you get these types of locators. Sometimes they're rather self-descriptive, like the link. Sometimes you get something like table 5, tbody, tr, and is there a problem with this? Well, it does map to some element on the page, but you might have experienced that the problem is it's not very readable. You don't know what the element is just by looking at the XPath, and furthermore, if the element were to change, the page structure changes a little bit, and your test breaks, how do you know how to fix it? Well, you probably have to go back and inspect the DOM again or re-record or something like that. What we really want is something which is a little bit more friendly, a little bit more descriptive, more like a natural language. It would be great if we could say, on the Google News page, click the 5th article link, right? Just go from saying it to doing it. Well, we can do something like that, right? Because there is something of a mapping between more natural language, like Article 5, and an XPath. And here's one example mapping. Here's another example mapping. The previous locator we saw could actually be recorded by the Selenium IDE, and was. But this one is a handcrafted one. It's an XPath that's a little bit more robust, and it won't necessarily break immediately once your page changes. And we can still refer to it with a natural language description, which is great. Now, how do we do this? Well, we try with UI element. Traditional locators are ugly, they break. When they break, you have to change lots of test cases, any test cases that use them. And also, if you're using some kind of API to encapsulate the traditional locators, chances are that it's very language specific. You won't be able to drive RC tests using multiple different languages. You're probably bound to Java or Python or something else like that. So UI element tries to overcome that. How does it do it? We introduce a new type of locator that's different from the traditional ones. It's not just dependent on the page itself. You can provide it information in a mapping file. And I think lots of different frameworks have tried to do this, but if you're providing a mapping that's defined in XML, as was mentioned before, it might not be as flexible. You can't really, you have to write special bindings if you want to drive it in different languages, if you want to use it in different languages. So UI element is actually 100% JavaScript. It's written as a Selenium core extension, and there are special additions for better IDE integration. Okay, so what does a UI locator look like? Excuse me. Here are some examples. We've got what's called a page set before the scope operator, the double colons. That kind of gives you an idea of what kind of pages the element would appear on. Then you've got the element name, which should be pretty descriptive as well. And then you have a number of arguments which can kind of qualify what that element is on the page. So you can have an arbitrary number of arguments and values, and it's specified in a kind of Python-esque keyword argument style. Hopefully that's pretty clear to look at. You know, if you see that in a test case, you know what's being referred to. Okay, so how do you define the JavaScript map? Sorry if I'm going too fast here. There's a shorthand, and it should be very straightforward to write your first map file. It's a JSON format. Every element that you define on a mapping for, you have to define a getLocator method. And that defines how you go from the human readable or more human readable UI locator description to the traditional XPath. That's what it does. It brings the element, the page set, the element, and the arguments to a traditional locator. Okay? And how do you start out this map file? You just instantiate the map in an extension by calling new UI map. You create a page set. A page set kind of encompasses several different elements. You can think of it as a single page or several similar pages. Excuse me. You just give the page set some metadata and tell it. You define the page set. You say, oh, okay, any page that contains this element or is like this is considered as part of the page set. Then you add an element to the page set, providing metadata for the arguments and also defining the getLocator function, which you can see here, takes some arguments and based on what they are, returns a traditional locator, an XPath in this case. I'm going to show you how this works in the IDE. In the options, I'm going to configure it for UI element, which is disabled by default. I'm going to add the map file as a core extension and enable UI element. For this extension to take effect, I have to restart the IDE. I'm running it as a sidebar. Okay, now I can go to alistapart.com. That's where what the map file is written against, and I can start recording. You can see that as I interact, the UI type locator is automatically populated into the recording list. And it's pretty readable. You kind of know what it's talking about. Some of the locators have arguments, and the argument values are automatically selected to be correct. There can be more than one argument, like I said before. I think that one on the bottom actually has 3. So I'm going to show you where the metadata comes into play. You can see any metadata that was defined in the mapping file down below, the example values for any of the arguments, what the arguments mean, also the traditional locator that's created by running getLocator with the arguments. You can see it at the very bottom. And you can also dynamically change the values of the arguments and see how the mapping to the locator is updated. Very useful for debugging. And now let's try running this. Indeed, the locators actually work. It's good to see. All right. So that's a UI element in action. The advantages, well, the map file is portable to different languages. It's written in JavaScript. You include it as a user extension in the IDE, in core if you want to, and even in the RC, it works perfectly. So you can drive your test in the RC in any language and take advantage of the map file that you defined. If something in the user interface changes, you just update the map file itself, and all your tests should magically start working again. Should, hopefully. And hopefully the syntax is pretty clear in the mapping file. I've taken particular care to make it as readable as possible and to make sure that you definitely give a description for each element and give a description for each different argument, because it will come in handy later. And JavaScript gives you a lot of flexibility when you're defining your getLocator method. You can do lots of different things to get that. Okay, drawbacks. Well, you have to program in JavaScript. Actually, I like JavaScript, but it can be difficult to debug problems. So to mitigate that a little bit, you can actually write test cases for the getLocator method, and they get run automatically whenever you start up the IDE. The other kind of drawback is in the way that the argument values are automatically discovered. when you're recording. It's kind of a brute force method. So if you aren't too careful when you're writing your UI elements, it can actually slow down the recording process, which is kind of, it's painful to deal with, but it's a drawback. We know about it. A couple things we can do about it. And lastly, the future of UI element, it's going to make it into core sometime. We'd like to have a visual map editor to make it, less daunting to create that first map file. And I think that it would be cool if the test cases that you write for get locator could actually run against real life pages that were, saved into a SQLite database or something, so that you would have, even greater confidence that your locators are working against the actual page. So that's it for UI element. Thanks.
There we are. That's me. Hi, I'm Corey Innis. I'm also from Pivotal Labs with Alex. And I'm going to talk about something we've been adding to our Polonium, Selenium, RC-Foo, Felonium, whatever you want to call it. Sort of a different use for Selenium than most of what you see out there. And so what we've got going is user interface characterization testing or regression testing, perhaps helping you with refactoring as well using Selenium. First I'm going to talk about what characterization testing is. Characterization test, this is somewhat taken from Wikipedia. A characterization test is a means to describe or characterize the existing behavior of a piece of software and protect that behavior against unintended changes via automated testing. So the basic premise is you take some gold copy of what things looked like before some changes, make your changes and then run your tests again, and in the case of a regression like testing, you want to see that nothing has changed. And why do we want to do that? That kind of thing in, this is really focused on sort of front-end development in web applications, so at the HTML, JavaScript, CSS level. The point here would be to get a step closer towards fearless refactoring. In addition, that's the exciting part, I think, in addition to general regression testing. So you might run in a couple modes. One, as individual developers, before you start making your changes, you would run a suite to store off your kind of gold master, and then perform a bunch of refactoring and run again and see that you haven't broken anything. Also, depending on what you find useful, you might have CI running the comparison mode all the time for, again, more regression-like testing. Why we chose Selenium? Well, first off, it gets me here at this conference. So, no, but again, it's like Selenium's got this great, built up this great ability to drive the browser, and all that I wanted to be able to add to that was the ability to assert things like CSS values on particular elements on a web page. So because Selenium also provides you this ability to sort of inject more JavaScript into its capabilities on the fly, it was all set up to do that. And I guess just to clarify, so here we are, current capabilities. What we've written so far will allow you to, again, run a suite of tests. They can be with the addition of one additional, in Ruby world, one additional include statement, your existing suite of tests. So that's really handy to be able to take your 51,000 Google tests and add one line, and all of a sudden they're all capable of doing this sort of CSS comparison as well. And what happens is, in the storage mode or the comparison mode, for each page, at each page load or for other wait for conditions, so it could be an AJAX interaction, JavaScript will walk the DOM of the page and store off a bunch of calculated style attributes, so border width, border color, and all these kinds of things, just under 100 attributes at this point, and save those off to a configuration file on your system. And subsequently, when you run the comparison mode, we'll run through and check every element once again and see whether or not anything has changed. Currently, that configuration file is stored as YAML with some very verbose, because I haven't hooked into UI elements, some very, very verbose XPath, which is very brittle. So that's both capability and drawback. Again, regression testing or driving of refactoring for DOM and CSS stuff, and it will catch, like I said. So, for example, you might have defined some styles as a style attribute on your paragraphs in your page, and you realize that you've got 20 of these paragraphs on your page. It makes sense to pull those out to an external CSS file. That kind of refactoring would succeed past this test, right? The applied style to those paragraphs hasn't changed, even though the structure of your code and your style sheets have changed. Real quickly, some plan for the future. I don't unfortunately have examples of the output with me available right now, but it's very cryptic output at the moment, although you do get to see that verbose XPath and what styles have changed. So I'd like to improve that usability. The ability to target specific components of the page would be really valuable. So, you might say, like, this component on any given page should always look the same. Maybe mapping of some desired or intentional changes. Mock-up driven development, if your designers were able to give you something saying, here's what it should look like, and you could write the code and assert that they end up matching something to maybe explore. And screenshot comparison. There are some plugins for Firefox, for example, that will allow you to take a little screen capture of a particular widget on the page. And I'd like to be able to actually drive that so that you can see whatever's changed. The DOM's changed, the CSS has changed, the JavaScript that rendered this thing has changed. It all still looks the same. And that's what I've got for you. Simon's up next.
I see why people are confused now. Hi, my name is Simon Stewart. I'm here to talk to you about WebDriver, which will be rolled into Selenium and become part of Selenium 2. So I guess the obvious first question is, what on earth is WebDriver? It's not a perpetual motion machine based on a buttered cat, but it could be. Instead, what I saw was that there were some nice features in Selenium. It covered too many browsers, covered too many operating systems. It covered the ability to create frameworks and stuff like that. But it had one major drawback, and that was that it was too easy to hack it because it was all written in JavaScript. So what I did was I decided to make it easy for the developers to write their frameworks. WebDriver started life as a developer-focused framework for writing automated web tests. And the concept was that you could make conscious trade-offs between speed, what I like to refer to as perceived and actual safety. So actual safety means, do my tests work? And that's a binary thing. They either do work or they don't work. Perceived safety is, do I believe my tests work? Now, you as an engineer may sit there and go, well, it all runs in memory and I don't have to see it, but I trust the tools, so my perceived safety is about the same as my actual safety. Whereas if you were to show it to your project manager who hasn't touched a computer in heaven knows how long, other than to play with Excel spreadsheets, then what you probably want to do is have some sort of visual thing clicking through the test so they can see it. And by being able to see something, the perceived safety goes up. The only problem is that running those actual browsers, that's a fairly slow process. So by raising your perceived safety, you can theoretically lower your speed. If you could run entirely in memory, really, you could go super, super fast. But you might not be able to cut to stuff like JavaScript, for example, because nobody does JavaScript in memory. So what does WebDriver look like? This is some sample tests taken from our test suite. You can see here, I think it's pretty readable. If you were to read out that third line, driver find element by XPath, fancy schmancy XPath there, and then click. Clearly you wouldn't read out fancy schmancy XPath. You can see that this is a nice focused API. And there are two key pieces of that API. The first one, two interfaces in the Java world. That's WebDriver, which represents a sort of idealized browser and gives the ability to load URLs by calling get, find elements on a page, go forward, go back, all the good stuff. And then there's a representation of the element on the page called web element. And that allows you to do things like click or get the text or submit if it's part of a form, for example. Now, that sounds pretty much like Selenium RC to me. It all sounds like fairly similar. So what's the difference? Well, the first thing is that it presents a blocking API. So with Selenium, the moment you execute something, it returns control to you. Generally what you'll see, however, is people go do something and wait for the page to load. That's a fairly common pattern that you see. So WebDriver presents a blocking API. The other thing is that it's not written in JavaScript. Each of the browsers has a natural language which is most appropriate for controlling it. In the Microsoft world with IE, that's probably using COM and the IE automation interfaces. In the Firefox world, as the IDE guys have shown, the natural fit is probably some sort of Firefox extension, and so on and so forth. Now, the advantage of writing on those native platforms is that you get the ability to break out of the jail that the JavaScript is running under, and you've got the capability of having novel solutions to difficult, intractable problems that you would have to solve with yet more layers of technology in the JavaScript world. So, for example, if you want to test an HTTPS website, a site over SSL, you can just use your browser. You don't need to instantiate a proxy and inject that in and put yourself in the middle of the requests. Like I said, each of the browsers has a particular mechanism that's best for driving it. So the IE driver is written in COM, in C++, and is exposed through a thin wrapper. So the individual libraries are pretty easy to do. The general design of it is that you put all the smarts in the natural language, like for the browser, and then you expose that somehow. So with COM, we export a set of symbols for a DLL, and every language out there, Ruby, Python, C#, Java, have mechanisms for calling exported functions and libraries. So to write and support additional languages is an easy thing to do. Writing the actual driver is a complete devil. Unless, hey, does anyone want to do some Win32 hacking? No, I didn't think so. But you never know. With the Firefox driver, all the smarts are running in an extension, and you just communicate with that extension by spooling not comma-separated values, but JSON across the wire. With Safari, there's an implementation that uses Apple events and sends those, because that's the technology that Apple have given you for playing and controlling with your browser. There's also in the Java world, in the Java language binding, there's support for running purely in memory using HTML unit. So the advantage of that is it's extremely quick. HTML unit out of the box does support JavaScript, but I've turned it off. And the reason why I've turned it off is because there is no browser out there that uses Rhino as its JavaScript execution engine. And I've seen teams dig themselves a big hole trying to fix a bug that doesn't exist. So there are some capabilities that Selenium will need in order for WebDriver to become part of it, or rather, WebDriver needs in order to become part of Selenium. One of those is one of the key features of Selenium is the ability to inject arbitrary chunks of JavaScript into your current DOM. Now I find that a bit distasteful, but it's a feature that a lot of people tend to rely on, and there are certain use cases where that's really valuable. For example, when you're obfuscating IDs for your elements and you want to be able to call the same JavaScript function to get hold of the element again. Or when you want to do CSS comparisons, for example. The other thing that's really important is backward compatibility. What you want to be able to do is take your existing Selenium tests, and when Selenium 2.0 comes out, you want to be able to just make that switch without having to incur a huge cost of re-engineering all your tests. So backward compatibility is something that we're focusing on. But we think the story is pretty compelling. I mean, the advantages are that you break out of the jail. And so with Selenium 2.0, I think the future's looking pretty bright. The future for WebDriver itself as an independent project is pretty grim. If you want to take a look at the current work, it's sitting on Google Code, webdriver.googlecode.com. But at some point, it will be migrating into wherever it is the rest of the Selenium code is. So I think that's all I have to say. But thank you very much for listening.
Next up is going to be Frank Cohen, and he's going to be talking about the company Push to Test and what they're doing with Selenium. Just pull that into power. Yep. There.
Yeah, I'm the only one also that didn't give Paul my slides today, so thank you for letting me do the switchover. Push to Test is Push to Test has been around for 5 or 6 years. We've developed a platform for running functional tests, unit tests, and business service monitors. And I'll show you a quick kind of map of what the environment looks like. We're 100% GPL, version 2. Basically, the box in the center is the push-to-test runtime. So, you know, if you've seen application server runtimes, we're kind of a testing runtime. The idea is that people using push-to-test will have already written a test. They might have used Selenium to do it. That test itself would probably be a functional test, meaning it'll kind of go from top to bottom, putting an application through a couple of different steps. And then the success of that test is whether the test finished. If it doesn't finish, then maybe an exception gets thrown as an assertion. What we try to do is leverage the work of developers and QA testers in a way that IT managers can benefit from. So let me just see a show of hands. How many of you would identify yourselves just as testers? And how many would be just developers? And how many of you would be both? Yeah, so now if I had asked the same question about 3 or 4 years ago, I remember speaking at conferences like the STAR conference and really getting criticized by the attendees of my talk when I was trying to implore them to learn how to code. So there's a whole lot of work that happens both in the testing world and the development world that could be reused if we had a way of turning these tests into something usable by, say, a test runtime. So what we've done with Selenium is make it possible so that you can use the Selenium IDE, for example, to record a test. Here's just your standard application, and it's watching what I'm doing, right? What we're able to do next is to export this test. And the test itself, it's a big test. Oops. Very good. It didn't want to, there we go. So what that's done is created a set of Java files. I'm sorry, here we go. I'm sorry, not Java, but Python files. And so what this has done is basically let the Selenium IDE user be able to express the same kind of test in a different language. We call it simple transformation. What you're able to do once you've transformed that into this other language is to be able to run it within the push-to-test runtime. The cool thing about the push-to-test runtime is that we have a very simple XML format for expressing what the test should do when it runs on a grid of test nodes. Test nodes are essentially the same push-to-test environment, but run as a web service. So you have like either a lab of test machines that are each running this test node software, or you might be doing kind of service monitoring where you've got a smattering of servers spread around your network. or you might be just running it on your laptop to do kind of functional testing. So what the XML here of this test scenario does is let you identify that this is going to be a load test. And then down here is a run method. And what we've done is to say, hey, we can run, say, a Python script, or we can run a JavaScript. So the marriage of Selenium and this push-to-test environment allows us to author tests using the Selenium IDE in all of its richness, and then be able to orchestrate either functional tests, load and performance tests, or even business service monitors using this test scenario description. So the plugin that we've created for the Selenium IDE is a contribution from Olivier and Dominique at a company called Denali over in France. They're a very good system integrator. And what we're expecting to do is to not only support their work, but also to provide a native Selenium runner so that within those test nodes of the push-to-test environment, we're able to natively instantiate a browser of your choice and using Selenium RC to operate those tests remotely. So all of the work that I've seen here is just goodness for the push-to-test community, and hopefully we'll be able to contribute back some improvements to Selenium itself. For example, one of the things that you need to do when you're in kind of a grid environment like this is to deliver operational data. So it's like, you know, what is the sign-in ID and the password and maybe the product that you're looking for? What we're expecting to do is to contribute back to the Selenium project the data production library technology that's built into the push-to-test runtime, so that we can give you access to a relational database, to a comma-separated value file, or maybe another web service call within Selenium IDE itself. That's my presentation. I'm very happy to see how much excitement there is for Selenium, because push-to-test has been very much an admirer of the project for a very long time. Thank you.